What's up everybody, welcome back to a new video. We begin a new chapter, which is chapter 6. In the previous lesson we talked about reflection, we talked about different types of mirrors, we covered plane mirror, then spherical mirrors, concave and convex, and we learned how image forms in each one of them. In this chapter we're going to talk about lenses, and the first section is about refraction. So if you remember, reflection was when light was hitting a surface and then it was bouncing off. For instance, you have a plane mirror, and then when light hits the surface, it's going to be changing its direction. This is what reflection was. Now, refraction is something quite different. Refraction happens when light changes the medium. For instance, light traveling from air to water or from air to glass. Okay, as you see in this image here, in this empty glass, if you put a pencil there, there's going to be nothing wrong with the pencil, but if you pour some water into it, you'll see that the pencil seems to be broken. What is the reason behind this? The reason is that when light comes from the air, okay, to water, it is changing its medium. Okay, when light comes and goes through water, it's going to change its medium. When it changes the medium, the speed of light is going to decrease, and this is what's going to cause a bending in light. That is why this pencil seems to be broken, because light is changing its medium. It is going from air to water. Okay, this is what basically refraction is, when light changes the medium and it bends. Okay, the bending of light, the bending of a wavefront, as the wavefront passes between two substances in which the speed of the wave differs. Okay, so a medium can be anything. It can be solid, liquid, or gas. It can be a glass, it can be for example, water, and it can be air too, or any other type of gases. Now we have basically all of this. All you see here, this one and this one and this one too, is basically this what I'm going to explain. So we have two cases when light refracts. Okay, let's say first of all, light goes from a less dense medium to a more dense medium. It is going from air to water. Which one is denser? Of course. Which one is more dense? Of course, water is more dense. Now remember, when we were studying reflection, we had normal line. Again, we have normal line. This is an imaginary line. It does not exist. It is just to calculate the angle. We have normal line here, and then let's say we have an incoming ray. Okay, let's do it like this. Okay, we have an incoming ray. If light goes from a less dense medium, okay, less dense medium, so this is less dense, to a more dense medium, so this is more dense, okay, which means the density of water is higher, then what is going to happen to the before that, let me write this too. This is called this ray that is coming is called incident ray. We studied that also in reflection, incident ray. The angle between the incident ray and the normal line, this angle, is called theta I, okay, which is the angle of incidence. If I told you to define angle of incidence, you're going to say angle of incidence is the angle between the incident ray and the normal line. Then let's go back to our note. When light goes from a medium which has less density to a medium which has a higher density, then this ray is going to be bending toward the normal line. Okay, this ray, the refracted ray, is going to be bending toward the normal line. So let's say this angle theta I is equal to 30, or let's make it 40, okay? Let's make this 40. When light refracts, okay, here, this angle theta R is going to be equal to 30, okay? This is called refracted ray, by the way. And then this is called theta R. Now, if I told you define angle of refraction, angle of refraction is the angle between the normal line and the refracted ray, okay? Now, opposite to that is when we have a ray that is going from a more dense, let's say, glass into air, okay, this time. It is going from, or we can say water to air, vice versa, it doesn't matter. Now, glass is denser than air, okay, is more dense than air, so again, we have what? We have normal line. Now, if we have an incident ray here like this, and this is theta I, and again, let's say this is equal to 25, this ray is going to be refracting. Now, if the ray is going from a medium which is having a high density, so this is more dense, this one is less dense, then the refracted ray is going to be bending away from the normal line, okay? So this is going to be, let's make that more clear. So this is going to be like this. So this theta I, let's say, is going to be equal to, just for the sake of explanation, is going to be 35, okay? This is theta R. So when light goes from a less dense medium into more dense medium, it's going to be bending toward the normal line. And if it goes from a more dense medium into less dense medium, it's going to be bending away from the normal line. And we have something else, okay? There are different ways to state this. I'm going to tell you each one of them. If the light ray this time is not going through the medium with an angle, okay? Let's say this time it is along the normal line like this, okay? It is a straight line along the normal line, okay? Or we can say it makes a 90-degree angle with the normal line, okay? Or we can say it is parallel to the normal line, okay? This is going to be what? This is going to be like this. There's going to be no reflection, okay? No reflection. When the incident ray is parallel to the normal line, then there's going to be no, sorry, not reflection, refraction, okay? Refraction. This happens when the angle is 90-degree with what? With the surface, of course, or the incident ray is along the normal line, or it is parallel to the normal line. Doesn't matter how you state it. Now, every substance has its own index of refraction, okay? If you want to take a look at these questions, here are these questions. It's basically the same questions as the topic that I explained before about how does light bend when it goes from one medium into another. Now we have something called index of refraction. What is index of refraction? Index of refraction, it's denoted by N. It is equal to C divided by V. We want to know how much, or what is the decrease, or what is the change in the speed of light when it changes from one medium into another. We have speed of light in vacuum, which is equal to 3 times 10 to the power of 8 meter per second. And then we have speed of the light in that medium, okay? We're going to calculate that too, and then we're going to get index of refraction. So as you see here, index of refraction cannot be less than 1. Index of refraction cannot be less than 1. If it's less than 1, then it means that we have a medium which is making the speed of light surpass the speed of light which is in the vacuum, which is not possible. Okay, so it cannot be more than 1. It's always less than 1. Sorry, it should always be more than 1, not less than 1. Now these are some indices of refraction for some substances. We have diamond 2.419. We have carbon disulfide, it's 1.628. We mostly deal with water, which is equal to 1.33. Air, which is equal to 1 point something, but we just say it's equal to 1. Even carbon dioxide, it's equal to 1.000450, but we say also it's 1. Just a small note, these are measured with a wavelength of 589. The relationship between the speed of light and the index of refraction is inversely proportional. As this index of refraction increases, the speed of light is going to decrease. Okay? So the speed of light decreases more in diamond compared to water or air because it has a high index of refraction. Now we have Snell's law. Snell's law, this is basically the repetition of reflection, which is we studied, about the electromagnetic spectrum when we studied visible light. It basically is analyzed into 7 colors. We have an acronym for this, which is ROY-GBIF. It denotes red, orange, yellow, green, blue, indigo, and violet. Most importantly, we have Snell's law. So Snell's law, if you remember, we had normal line, okay, and then we have the first medium, let's say it's air, and the second medium, which is glass. Okay, now if you have an incident ray, okay, it's going to be, of course, bending toward the normal line. Let's say you know this angle, which is equal to 25, but you don't know this angle, which is theta r, is equal to what? You don't know. But we know that the index of refraction of air is equal to 1. Of glass, it is equal to 1.52. Okay, and this is n. Now, the first medium, let's say the question tells you that the index of refraction, find the angle of refraction for a light ray that goes from air to glass. So this one becomes Ni, and this one becomes Nr. So the first one becomes Ni, and the second one becomes Nr. How do we calculate this? How can we find this theta r? Using the following equation. Ni, which is the index of refraction of the first medium, sine theta I is equal to what? It is equal to Nr sine theta r. Okay? Whenever you are trying to find the angle, always calculate it and then take the sine inverse of it. Let's solve a question. Okay? We have question 1. Sample problem 6a. Sample problem 6a says what? It says, by the way, it has given wavelength. When you're dealing with this, like, just leave the wavelength alone, okay? A light ray of wavelength 589 nanometer produced by a sodium lamp traveling through air. So first, we know it's traveling through air. So air becomes Ni, strikes a smooth, flat slab of crown glass at an angle of 30. So we have crown glass, Ni, which is air, is equal to 1. And then we have crown glass. Let's take a look at the table. If we take a look at the table, you will see that, I don't know, for some purpose, for some reasons, the screen is not moving. So I'm just gonna tell you, Nr is equal to what? Nr is equal to 1.52. If you go back to the table, you'll see that crown glass is equal to 1.52. Okay? Now it says what? Find the angle of refraction. So theta r is equal to what? Now we have theta I, which is angle of incidence, is equal to 30. Now how can you know which one is theta I, which one is theta R? Now, look at the question. It says, light traveling through air strikes a smooth, flat slab of ground glass at an angle of 30. So it is hitting the ground glass with an angle of 30. Okay, it's not refracting. And then in the second part of the question, it says find the angle of refraction. So this one directly becomes theta I. Okay, now let's solve this. Ni sine theta I is equal to what? It is equal to Nr sine theta R. Okay, it doesn't matter. You can just make this one N1 theta 1, N2 theta 2. Doesn't matter as long as you don't mix them together. We're trying to find sine theta R. Okay, Ni is equal to what? It's equal to 1. Sine theta I is equal to what? It is equal to 30. So sine 30 is equal to what? It is equal to 1.52, which is Nr here, times sine theta R. Okay, I'm trying to find this one. Take sine of 30, you're going to get 0.5, but I'm going to just divide here. So we have divide this by 1.50 and divide also this one by 1.50. Cancels. Sine theta R is equal to what? It is equal to, if you multiply 1 by sine 30, it's still sine 30. So sine 30 divided by 1.52. Take sine 30 and then divide it by 1.52. Let's do this. So we have sine 30. Use your calculator. You're gonna get 0.5, and then divided by what? Divided by 1.52. You're gonna get what? You're gonna get sine inverse, this one here. Let's do this here. So sine theta R is equal to what? It is equal to 0.328. Okay, then we're gonna take sine inverse. So theta R is equal to what? It is equal to sine inverse of this number. We got 0.328, and then theta R is equal to what? It is equal to 19.2. Okay, that's it for today. If you have any questions, please comment below. In the next lesson, we're going to solve practice 6a. See you in the next video.